Hi, happy Friday. So, as you know, I am not at school today. I woke up this morning and my son said, Daddy, I don't feel good. So I'm like, okay. And he had a temperature, so he needs to stay home. So I quickly drove to school, whipped up some sub plans, and made a video to go along with our PowerPoint today. So you should have already have checked your answers for 10.2 when we were learning about minor arcs, major arcs, semicircles, central angles, and how we figure out the measures of different arcs. Well, now we're going to go back to something we learned in 10.1, which was this idea of chords. And so remember, from this picture over here, we have all these different types of lines and segments that occur in a circle. But a chord is when it starts on the circle, one endpoint's on the circle, and extends to a different endpoint on the circle. That's what a chord is. So when you have a secant, this one in green, the section from this point to this point is still considered a chord. If you look at this picture over here, these are just four different examples of chords that can occur in a circle, with PQ being a diameter, which is the biggest possible chord, or the longest possible chord that exists in a circle. So today is going to be all about chords. And so the first theorem we're going to look at is if you're in the same circle or different circles that are congruent, if you have congruent chords, so if AB and CD are congruent chords, then the arc that stretches from B to A and the arc that stretches from C to D, those also have to be congruent arcs. So basically it works like this. If you have congruent chords, you have congruent arcs. Or if you start knowing that you have congruent arcs, then you have congruent chords. And so it works out really nicely because it goes both ways. And so in this picture, two different circles. First ask yourself, are they congruent circles? The answer is yes, because this radius here with the two marks and this radius here with the two marks, that means they are congruent radii, which means they are congruent circles. So then if JK, JK always funny, and GF are congruent chords, which they are because of the tick mark, well, if this arc right here is 80 in relation to this chord, then this arc right here is also 80 in relation to that chord. So we'd set it up that way, and they would both be 80 degrees. Okay, the next one, the perpendicular chord bisector theorem. So think about the words in that title. Perpendicular, two things that are coming together to make a 90-degree angle. Chords, so that means two chords that are perpendicular to make a 90-degree angle. And then the word bisector. Bisector means to cut something in half. So in this picture, how it works is if two chords are intersecting and one of the chords is the diameter. So EG is the diameter, it's intersecting with FD, and they are perpendicular to each other. If they are perpendicular to each other and one of the chords is the diameter, two things happen. This other chord gets cut exactly in half, it gets bisected, and the arc associated with that chord also gets cut in half. So the chord FD, H becomes the midpoint, so FH equals DH, and then from an arc standpoint, arc FG is equal to arc DG. So the bisector part of this theorem, it actually happens for two different things. The chord is being bisected, and the arc made by the chord is bisected. But again, that only happens if a diameter and a chord are perpendicular. You get congruent arcs here and here, and congruent segments from DH and FH. So here would be an example of that. You have a diameter here. I know because it goes to the center point. It's perpendicular to this chord right here. So what two things happen? This chord HK gets cut in half, and this arc right here also gets cut in half. So I know that HM equals KM, and then arc HJ equals arc KJ. So for the first question here, find HK. Well, if NK is already 7, and I know it got cut in half, that means NK is also 7, and then of course 7 plus 7, or 7 times 2, is 14. Now to solve the second part of this, the two arcs are going to go on to the next screen. Same picture, everything's the same. And so what we have here is this arc set equal to this arc. So 11x equals 7 plus x, and then some simple algebra, and we know that x equals 7. Okay? And then it was asking me for the measure of the arc, hk. So I have to plug 7 back in for this x right here, and 7 back in for this x right here. So 11 times 7 is 77. 70 plus 7 is 77. 77 plus 77 is your 154 degrees. Okay, now the converse is just that. If I know that one chord is the perpendicular bisector of the other chord, so if we know that this chord right here and this chord right here are perpendicular and bisects this one, then I know that SQ must be the diameter. It's just the converse of what we already learned. The first one said, I know it's a diameter, I know it's a chord, and they're perpendicular, and therefore cuts the chord in half. This one's saying, if the chord is cut in half by another line, as SQ is that other line, SQ must be the diameter. All right, so this goes back to you practicing some of the theorems. I have congruent chords, therefore I have congruent arcs. So if arc AB is 110, that means BC would also have to be 110 degrees. And then if AC from here to here is 150, what would the arc of this one be? And we have 150 plus 2 ABs. Why do they do 2 ABs? Well, because I know AB and BC are the same. So I'm just doubling it. I'm saying, well, I know they're the same, so I can multiply it by 2. So if AC were 150, take that away from 360, and what are you left with? 210. So then 210 divided by 2 would give you 105 for both of these congruent arcs, but we were only solving for AB, so AB is 105. All right, what do we have here? This is a diameter. It's perpendicular to this chord, so it cuts this chord in half, and it cuts this arc in half. So if CA is 5, I know EF is also 5, and then CE total would be 10. And then to solve for CE, this whole arc, I first have to solve for x by setting 9x equal to 80 minus x. Solve for x, take that 8, plug it in here, and plug it in here. And your total is 144, because each angle by itself was going to be 72. All right, now, this last one. This one is probably the hardest one. All right, sorry about that glitch. So this one's probably the hardest one, but what you'll find is it all comes back to triangles now, and you will be using Pythagorean theorem. So in this picture, there's a lot happening. Look at what you are asked to solve. You are asked to solve what is the radius of this circle. As you look at this picture right now, it doesn't seem like we can figure that out, okay? However, look at the information that we know. It says QR and ST are both 16. So QR right here is 16, ST right here is 16. Now, notice that QR is perpendicular to XW. Well, XW being the diameter, when it's perpendicular to a chord, what did we already learn today? It cuts the chord in half. So I know that QU and RU are the same. So if QR is 16, then I know from Q to U is 8. That's important. So QU is going to be 8. Then it tells us that UC is 2x. Okay? How's that going to help us? Watch this. So we have the same picture over here, but what have they added to the picture? They've added a radius. I think I might need to move this over for you to see better. We'll try that. So the radius here stretches from C to Q. C to Q. Well, all of a sudden, notice what we created. When we connect C and Q, and we have CU, and we have UQ, we have ourselves a right triangle. And in this right triangle, we know that CU is 2x. We know that QU is 8 from what we talked about before, and then QC would be the hypotenuse. Okay, so that's important, all right? Now here's the other thing that's fun to know. QR and ST were congruent chords. That means they're actually the same distance from the center point. So I know that 2x and 5x minus 9 are actually the same. Okay, so we can actually find CU by setting 2x equal to 5x minus 9. That's what we do here. And this tells me that x equals 3 when I do the algebra. So if x is 3, imagine we put a 3 here, and 2 times 3 is 6. So now CU would be 6, QU is 8, and we can solve for the hypotenuse by doing Pythagorean theorem, which I'm now going to go through on the next slide. So here's our right triangle. And remember that the same given information. This is now 6 because we solved for x is 3. QU is 8 because it's half of 16. And now I can, and this is what that shows right there, it's 8. And then I can do Pythagorean theorem. So it'd be 6 squared plus 8 squared equals blank squared. Well, that gives us our traditional 6, 8, 10 triangle, because 6 squared 36 plus 8 squared 64 equals 100. Square root of 100 is 10. So it seems like a long-winded problem, but all you're really doing is drawing the radius to make the right triangle, and then you will know enough information for 2 of the sides to figure out the third side. So let's do another example together. So here we go. We have almost the same situation. We have diameter perpendicular to a chord. So I know JK, always funny, is cut in half. So PK is equal to PJ. And they tell me that JK is 24. And LM is also 24. So congruent chords, meaning they're the same distance from the center. Okay, so we're going to basically do the same thing we did last question. If JK is 24, I know from P to K is 12. And then, to help me solve for the red leg, I know the red leg and the blue leg here, or segments I should say, they're equal to each other because their congruent chords are the same distance from the center point. So 3x equals 7x minus 12. So I do that, and I get x is 3. We'll take that 3 and put it right here. 3 times 3 is 9. So I have a leg that's 9, and I had a leg that was 12. So by Pythagorean theorem, 9 squared plus 12 squared equals this hypotenuse right here squared. Well, that ends up being 81 plus 144, and that equals 225. So the square root of 225 gives me 15. So I'd have a 9, 12, 15 right triangle. And the radius of the circle would be 15. Okay? All right, so these are taken directly from the book. So if you want to look back at the book, or you can rewatch the PowerPoint if you'd like. Your assignment today is 1 through 11, and then 13 through 17. You have the rest of the class period to work on it. And we are going to have a quiz on Tuesday from lessons 10-1 through 10-3. So we'll use Monday's class to review and prepare for that. All right, hope you have a good day, and I hope you have a great weekend. See you on Monday.